Hi, this video I'm going to tell about the programmable DMA controller interface. So the chip number 8257. So we go into the video. So what is meant by DMA? Before going to discuss the programmable DMA controller, I'll tell about what is meant by DMA. So DMA stands for direct memory access. So it was designed by Intel actually. The purpose of this DMA is it is used to transfer data at the very fast rate. So for that purpose, this DMA was designed. So, and another advantage is it allows the device to transfer the data directly to and from memory without any interference from the CPU. There is no CPU involvement in DMA. So it allows the device, any peripheral device, to transfer the data directly from or to memory without any interference from the CPU. So for that, what the device need to do is, using a DMA controller, the device requests the CPU to hold its bus lines. There are three bus lines used, that is a data line, address line and control bus. So the device is free to transfer the data directly to or from the memory. So when the DMA data transfer is initiated, it is initiated only after receiving the hold acknowledgement signal from the CPU. The name of the signal is HLDA. What is HLDA signal is? It is a hold acknowledge signal. So this is a signal that is used only the DMA data transfer is initiated after receiving the hold acknowledgement signal from the CPU. So this is an introduction about DMA, and these are the different features of the DMA controller. So the DMA controller contains 4 channels, so which can be used over 4 IO devices. So at the same time, 4 IO devices can be used 4 channels to transfer the data directly from the memory. So each channel has 16-bit address and a 14-bit counter. So how many data it can transfer is, each channel can transfer up to 64 kilobytes of data. So and each channel can be programmed independently. So each channel can perform read transfer, write transfer and verify transfer operation. So once the transfers have been completed, it generates mark signal to the peripheral device that 128 bytes has been transferred, and it requires a single phase clock, and its frequency ranges from 250 to 3 megahertz, 250 hertz to 3 megahertz. So this is a feature about DMA controller, and this is the steps to transfer the data from memory to peripheral device with the help of DMA controller. So initially, any device has to send the data between device and the memory. The device has to send the DMA request to the DMA controller. So the name of the signal is DREQ. So DREQ signal. So this is a signal DREQ. So that signal the device has to send to the DMA controller. Once the DMA controller sends the hold request to the CPU, it waits for the CPU to accept the hold acknowledgement signal. So the DREQ signal actually DMA request signal. Once the DMA controller accepts the request, it will send the whole DMA acknowledgement signal back to the device. So now the DMA controller is ready to transfer the data. So to transfer the data, what the DMA controller needs is, it needs a bus lines. So for that, the DMA controller sends the hold request to the CPU and waits for the CPU to accept the hold acknowledgement signal. So once the hold acknowledgement signal is received from the CPU, now the DMA controller is ready to use all the bus lines, that is a data bus, address bus and control bus. So this allows the CPU to leave the control over the bus and acknowledges the hold request through the hold acknowledge signal. Now the CPU is in hold state, and the DMA controller has to manage the operations over the buses between CPU, memory and IO devices. So these are the steps for the DMA operations, and this is a block diagram. As I told, so this is a DMA controller. So this DMA controller contains 4 channels. So channel 0, channel 1, then channel 2 and channel 3. So each channel has 16-bit address and a 14-bit counter. So every channel have two signals. One is a DMA request and other one is a DMA acknowledge. So what is DMA request signal is? So whenever any peripheral device wants to transfer the data using DMA controller, it first sends a DMA request to the DMA controller. Once the DMA controller accepts the request, in reply it will send the DMA acknowledgement signal back to the peripheral device. So these are the DMA request and this is the DMA acknowledgement signal. And here we have a data bus buffer, so it is used to hold the data that is transferred between processor and peripheral device. Then we have a read write logic, then control logic and mode set register. So these are the signals that are related to 8257, that is a programmable DMA controller. We will see one by one what is the use of each and every signal. And this is a pin diagram. So pin number 1 IO read, pin number 2 IO write, pin number 3 memory read, pin number 4 memory write, then pin number 5 mark, pin number 6 ready, pin number 7 hold acknowledge, pin number 8 address strobe, pin number 9 address enable, pin number 10 hold request, then pin number 11 chip select, pin number 12 clock, pin number 13 reset, then pin number 14 and 15 DMA acknowledgement, 16 to 19 DMA request signal, pin number 20 it is a ground signal, then pin number 21, 22, 23 data bus signal, and 24, 25 DMA acknowledgement, again pin number 26 to 30 data bus signal, pin number 31 it is a power supply, so pin number 32, 33, 34, 35 address line, pin number 36 is terminal count, 37 to 40 again address signal. You'll see one by one what is the use of every signals. First one, it is a DMA request signal. As I told here, the DMA request signal it is used by the different peripheral devices. So there are 4 channels available. So we have a separate DMA request input is available, which are used by the peripheral device for using the DMA services. And here DRQ0 has the highest priority and DRQ3 has the lowest priority among them. Whenever one or more channels are requesting the DMA controller at the same time, based on the priority it will be executed. So DREQ0 is having the highest priority and DREQ3 is the lowest priority. Then DMA acknowledgement line, this is again used by the DMA controller. Once the DMA controller accepts the request, to acknowledge that it uses the DMA acknowledgement line. And next one, it is a IO read and IO write. So IOR means it is a IO read, IOW means it is a IO write. So what is IOR? That is IO read signal whenever it is an active low bidirectional tri-state input line, which is used by the CPU to read internal registers of the 8257 in slave mode. Whenever any data that CPU wants to read from the internal registers of the 8257, this signal should be low. Whenever it is in slave mode. Whenever it is in master mode, it is used to read data from the peripheral device during the memory write cycle. So this is a IO read. Similarly, IO write. So IO read means it is used for reading the data, and IO write it is used for writing the data to the DMA address register. Then clock. CLK. CLK means it is a clock frequency signal which is required for the internal operations of the 8257. Then a reset. So the reset signal is used to reset the DMA controller by disabling all the DMA channels. Then this is the address line A0 to A3. So these are the 4 least significant address lines A0 to A3. So there are 2 modes. One is a slave mode and other one is a master mode. In the slave mode, they act as an input which select one of the registers to be read or written. In the master mode, they are the 4 least significant memory address output lines generated by the 8257. This is the address line, that is lower order address line. And CS, what is CS denotes for is CS denotes for chip select. So whenever 8257 wants to read or write, perform read or write operation, this signal should be disabled, that is active low. So in slave mode, it enables the reader or write operations to or from the 8257. In master mode, it disables the read or write to operations to or from the 8257. Then signals A4 to A7. Again, these are the higher nipple of the lower byte address generated by the DMA in the master mode. Then hold request and hold acknowledge. So as I told already, so this signal is used by the DMA controller to request bus from the processor. Okay, so this signal is used to receive the hold request signal from the output device. And hold acknowledge, again it is generated by the processor to the DMA controller. So it is an acknowledgement signal which indicates that DMA controller that the bus has been granted to the requesting peripheral by the CPU when it is set to 1. That is a hold acknowledgement signal. Then memory read and memory write, MEMR it is a memory read signal, and MEMW it is a memory write signal. So whenever it is low, that is memory read signal, which is used to read the data from the addressed memory location using DMA read cycles. So wherever data addressable memory locations, so whatever data available in that memory locations, addressed memory location, it is used to read. Similarly, memory write. So memory write means it is used to write the data to the addressed memory locations during the DMA write operations. Then address strobe ADST. So this signal is used to convert the higher byte of the memory address generated by the DMA controller into latches. Then AEN. So AEN means address enable. So this signal is used to disable the address bus or data bus. And TC, what is TC denotes for? TC denotes for terminal count, which indicates the present DMA cycles to the present peripheral devices. And VCC means it is a power supply signal. And mark, what is meant by mark signal is it will be activated after each 128 cycles or integral multiples of it from the beginning. It indicates that the current DMA cycle is 128 cycle since the previous mark output to the selected peripheral device. Thank you.